So in this video we're going to talk about change of basis of a vector using matrix multiplication. This is, by the way, section A in the notes. In the notes, this is at the beginning of the chapter. I just decided that for the videos and the whiteboard, it would make more sense to start with eigenvectors and eigenvalues and later talk about change of basis. The reason why we are doing change of basis in this chapter of eigenvalues and eigenvectors is that the change of basis is needed for the main application of eigenvectors, which is diagonalization, which we will see next. Okay, but first we need to understand the change of basis matrix. So what does it mean if I tell you that a vector v, I write it as a column vector, let's say with two components to start simple, and I say that this is written in the basis e1, e2. So what does this mean? You know what it means. You know it from the first chapter of vector spaces. You know that this means that vector v is a linear combination with the coefficients v1 multiplied by e1 plus the coefficient v2 multiplied by the vector in the basis e2, right? That's the definition of the components of a vector in a certain basis. And you know that you can write the vector differently, so the same vector can be written using a different set of two numbers, let's say v1 prime and v2 prime, in a different basis, in a new basis. So let's call the new basis v1 and v2, okay? And this will mean that the vector v prime is equal to v1 prime times the vector basis v1 plus v2 prime times the vector basis v2, right? Now, how do you convert from one basis to another? Well, you learned how to do this in the first chapter of the module by solving a linear system of equations. But here we're going to solve it in a different way. We are going to use matrices. So the way we do it is we use a change of basis matrix. And this change of basis matrix is built as follows. So our change of basis matrix A will have two columns. The first column will be the new vector v1, and the second column will be the new vector of the basis v2. Okay? So the columns are the vectors in the new basis, the vectors of the new basis. Sorry for that. I misclicked somewhere. Okay, columns are the vectors of the new basis. But so these vectors, we have to write the components in order to create this column vector. So this vector v1 has to be written in the original basis e1 and e2. Okay, so written in the old basis e1 and e2, while the new basis is v1 and v2. Okay, so using this matrix we can now change from vector v prime into vector v. So this is how it works. So vector v is equal to A times vector v prime. Okay? In order to prove it, it's very simple. So A times vector v prime is equal to this matrix, which has column v1 and column v2, times vector v prime, which is v1 prime and v2 prime. So if you do a matrix vector multiplication, you can say that the result is v1 prime times the first column, which is vector v1, plus v2 prime times the second column, which is vector v2. And since these vectors v1 and v2 are written in the old basis, this expression here is simply the linear combination that we want. So this is equal to v written in the old basis. Okay? So using this matrix, we can change between the new and the old bases. We can of course do the opposite. So if we multiply times the inverse of A on the left of this equation, so we multiply times the inverse of A here and also here, so these two a to the minus 1 times A will go to the identity matrix, and we will be left with a to the minus 1 on the left. So a to the minus 1 times V equals identity matrix times V prime, which means that V prime is equal to a to the minus 1 times V. And let me remove this. So these are how we can convert from one basis to another, using this matrix or using its inverse. Okay? Now, it's a bit tricky to remember what is the order. So do I have to use A to convert V prime into V, or do I use A to convert from V to V prime? So it's tricky to remember, right? So don't worry, in the actual exam I give a list of formulas and I literally write to change of, so the change of basis matrix to change from basis B1, B2, B3 into basis X hat, Y hat, Z hat is this matrix here. And here I write that this is the vector written. So this notation using a subscript with the basis means that this vector is written in the basis X hat, Y hat, Z hat. And then this is our matrix A. And then this vector is the vector written in the basis B1, B2, B3. Okay? So that way you won't have to remember it. So let's clarify these concepts by looking at an example. See you in the next video.